Welcome back to part 2 of the Redis Cache and Spring Boot applications session. I'm Sashi Peri, Principal Architect with ADP. Let's recap what we covered in part 1 and see what we are going to do in part 2. In part 1, we spoke about what is distributed caching and its importance. We saw why use Redis as your distributed cache manager. We also discussed a few famous caching patterns for APIs in particular. We created 2 sample REST APIs with Spring Boot, one customer API with MySQL as data store, and then Books API to simulate third-party API calls and network latency using Google Books public API. Then we incorporated a few caching patterns into these APIs using Spring Data Redis, and we cached the data in JSON format. But we did not incorporate any security. It used a default user that has no password, no restrictions on whatsoever, which is not acceptable in real production grade applications. Now in part 2, we will fill that gap. We will cover the security aspects. We will see how Redis on the server side implemented the security, and then how to manage the users and access on the Redis server side. And then on the client side, we will use the same Spring Boot application that we built in the part 1, and we will incorporate the security into this Spring Boot applications. And we see what happens when a user has access these APIs, and when the other user that do not have access this API. Then we will also look into 2 Redis modules, RedisJSON and RediSearch, and see how these 2 modules will make a powerful combination in searching the data that we previously cached in JSON format. Now, without any further delay, let's jump into the content. Now let's look at the server-side aspect of the security and how Redis implemented the security. Redis uses access control lists to apply policies, create policies, and thereby achieve the security. And the other popular one being RBAC, which is role-based security. And a typical output of a ACL command such as ACL list would look something like this line, which has 7 parts. I cut them into 7 parts to explain. So it is like user, admin, on, no pass, a tilde something, ampersand something, plus something. These are the 7 parts. And let's see what each of them means. The first one, user, it's always user to say this is a user. And the second one is the username. Here in this case, admin is the username. And the third one tells you whether the user is on or active or inactive. So the values that it can take are on or off, on being active, off being inactive. And then the fourth one is here in this case is no pass, but that denotes the password of the user that we are going to use to authenticate, login using that username. And no pass is a special keyword that means there is no password, which was the case in our previous example because we used the default one that has no password. And but if you choose to add a password, if you choose to have a password for the user, it's not an option actually. You must have to have a password when you created a user. Then you use this symbol, that's the less than symbol, the greater than symbol, sorry. uh, Ignore the equal to, it's just this, and then that's the prefix and supply the password, and that's how you create that's how you add the password. And then the tilde, the fifth token, this tells the keys, the key prefix. Star means everything. So you say that this user can access all the keys prefixed with this. Remember the prefix that I configured in the previous part 1 demo using a Spring property, which is what we will use now, which is what is going to come handy. Because all the properties under the application that we built are prefixed with one single thing to group them together. And then the ampersand. This is something to do with the pub sub and what channels a user can subscribe, which I'm not going to demo. So I'm not going to go deep into this. And then the last one, the plus sign. This is again an important one. It tells what kind of commands can this user execute: read type, write type, delete, and so on and so forth. And it's prefixed with plus. And at all is a special thing. It tells everything, every command which you don't want to do. You want to limit the commands ideally. And this is in a nutshell, and it's just basics of the ACL. There is more to explore, but I covered the basics that are required for our client to implement security. Now, the client side. And before we go to, we will see a demo using the UI, and we will execute few ACL commands, but then let's quickly see what we are going to do on the client side. On the client, implementing the client security on the client side in the Spring world is very easy. It's via few properties, application properties. We will see what those properties are. And the next thing is um, demo. Let's get back to our Redis site, and we are still in this instance. Let's go to the CLI, and let's see what's going on here. Okay, yeah. So now let's do ACL list. So it has 3 users. I have to delete this user, never do this. But I pre-created few other users. I will show how actually you can create the user also. So here it says Shashi Peri, it's an active user, and some password that's hashed, and it has access to everything that has a prefix demo cache. And there is another user I created, Shashi Peri 01, and it has access to something called music. Now you see why I created the music thingy. So now let's see how you can create a user. A real command we will execute. There is this user existing, but we can still one more time do it and then see what happens. For example, let's create a user. So see, maybe 02 user that has access to music star, or yeah, let's do that. And now again execute. It remembers the previous command, and it's available here, as you can see. Now let's see the difference with like what these users can do. Let's see from the CLI by authenticating each user. For that, I'm not going to do it using the CLI available on the Redis site. Instead, I will start my CLI. Okay, so now we are connected to the Redis instance. Now let's do this. Keys start to see all the keys. And this is the default user that we originally used in the Spring Boot application. This has permission to do everything on every key and every operation. Now let's do a few things. Let's try to read the content. This is from the demo class application. Everything, yeah. It retrieved the JSON. So it is able to read something that has this prefix. And then now let's retrieve something that is on the music application. It's able to read the data here as well. Now let's switch the user. Now let's authenticate as probably the Shashi Peri user that I created, which was given the permission on the demo cache. Let's see, and username and the password, I think 1245. Now let's try to execute this. Let's try to access something that has the music prefix, potentially probably an application called music. So Redis says I don't have permission, no permission to access this key. Now let's try the other one. It has permission. Similarly, let's try the other one. See, I think it was 01 if I remember correctly. And the password is, I think, 1 2 3 4 5 6. Oops, I connected off of the server. Let's auth CPD01 1 2 3 4 5 6. And now let's try to retrieve the same thing. Now let's try to retrieve the demo cache prefix. No permission, as it rightly doing how it is supposed to, because this user should not have permission to read that, but it should have permission to read music instead. Yes, it does. So now that shows that it proves that one user has no permission to read everything that's put under the demo cache, and the other user has permission. Now let's see how we are going to incorporate that into the application, the Spring Boot application. Let's open our Spring Boot application again, the same old one, and let's see how difficult it is to incorporate the the security. Now let's again inspect our application.yaml, and yeah, this is the prefix again is coming at application level from here. Like I said, I can group all the keys for this application under this prefix. That's the intention. And now look here. Let's now use the user that has access first, and then we see what happens when we use the other user. So this user has access to this application, I mean the cache under this application. Now I think that's all we have to do. Let's test. It's just 2 properties and everything magically happens. Now let's go back to our Postman, and yep, I can access with no problem. Now let's do another API. Yes, I can access, no problem. Now let's see, activate the other user. And stop the application and restart. Let's now see what's going to happen. Internal server error. I don't know why. It's internal server error. And internal server error. Not good. You don't want to do that. You don't want to present the end user with a internal server error. Behind the scenes, it's the no permission, as it rightly supposed to do. But let's handle this a little more elegantly. Instead of presenting it as 500 error, maybe we have to do a better job. Let's see. to do that, we can make use of our the controller advice. Let's go back to the controller advice, and the exception that it threw is Redis command execution. So now, like every other exception, now let's go back and uncomment this piece of the code. This piece of the code is converting the 500 error into something else. It's a forbidden error. Let's see what the forbidden error is. The forbidden is, oh, that's the exception. Now I want to check what this forbidden is. The forbidden is 403. So we are converting 500 into 403, and then we are not exactly going to say that your permission is incorrect or Redis is not able to. We are not going to be that explicit to give a clue of it's the Redis permission error, but at least some friendly error. In this case, I think I'm going to leave this not allowed and see what happens. Let's go back to the postman. 403 forbidden, the custom error code not allowed. In a real world situation, I don't think you would do even this. I don't think your security folks are going to like presenting this kind of an error, giving a clue that something is not allowed. It's a 403 a permission type issue. In these cases, all 300 or 400 forbidden kind of situations, the security situations, usually they don't want to give any, they don't allow to present the external customers with any specifics of the issue, especially if they are pertaining to security, and let the hacker probably brute force. So you have to follow your company's security rules and the recommendations and guidelines around the security error, and then configure code accordingly. But this is just an example to show how the 500 error can be converted into more meaningful error. That's all I'm trying to do here. Now with now this is done. Now let's see the other thing, the interesting thing, like how the Redis JSON and Redis search together make a powerful combination. To do that, I'm going to switch to the other instance, that's Redis Stack Server. The reason is this. Let's see that why I have to go for that a different type of Redis instance, not the default OSS one. Now if I go here, RediSearch, it's not available. That module is not available here by default. So, remember I said you can achieve more functionality, more data structure, more anything by including more and more modules. Now I cannot include it here, but they come out of the box with the other type of the Redis stack instance that I created out of the box. They are two different Docker images to begin with. And one more thing I wanted to show you before I move on to the other part of the demo is this, the client list. It's supposed to show the name. I don't know why it's not showing the name. Maybe I don't have a name. Let's see. The client, Redis client name. I think it's not here. Maybe it's in the demo cache. Oh yeah, the client name is there. It's supposed to populate. So I don't know what went wrong here, but let's refresh. Yeah, the name is supposed to come here when it connected to this, or it's not connected. Maybe that's why. Let's no, it is to connect. Oh, it did not. The reason is it never posted in after I restarted, so it never registered. To make it work, let's do this. I'll put some random name, and here also I'll change something. I hope this is a valid one with the Google API. Oh, did I stop it? Oh yeah, I stopped the server. Let's start it. Oh, that explains. That's why it did not appear there. But then let's see now. Refresh and go to the postman and hit the API one more time. Oh, it's forbidden. Nevertheless, see now, the moment it tried posting or tried connecting, tried doing something using this client, so the name populated. This is useful, like I mentioned in the part 1, for the administration purposes. Now let's move on to the next part of the demo. Redis Stack Server. Now here, unlike the other one, it took a while. So there is these modules, RedisJSON and RediSearch are enabled. So what this means to us, how is this useful? Let's see. Using the Redis CL. Oh, first let's see what's in this. So I there is this customer key I created to simulate the customer aspect of it, and there is this book API. I have it's a humongous thing. It's not shown here. It's a big blob. It's a big document, not blob. And the other one, it's a humongous one again. That plus sign, it means it's a big one. Um, and I must be having a JSON. Yeah, see this customer 03, I named it under com 03 has similar a payload similar to the customer payload. Now let's see. These are all basically JSON, and I copy pasted exactly the response that was coming from the Google here. It's that. Now let's see how the Redis JSON can be used to do the searching operations. Now to the CLI. We saw few CLI commands where the keys were fetched. The whole JSON was presented in a not so readable format. Now let's use the JSON to do some things. The first one, I want to do the JSON get. Maybe we will do the whole book and see what happens. It returned me the whole thing. Now I said that you could use the path, right? The JSON path, and let's see what that how that looks like. So now how we do that is like this. Let's say I don't want the whole JSON, but I want to query by the path. Now the dollar is the root, and from there let's pick something which is like ID. Now it's the ID. Now similarly, I think let's pick some other path. The path probably would be, I think, if I remember the response correctly, it's the volume info title. Volume info dot title. That's probably not correct, but this is how you would search. To make sure that the we are typing correctly, let me try one more time. Oh yeah, I think I see why. It's a capital. See, it exactly fetched that, and it's limitless. I could go everything that's possible with the JSON path is possible here. And this is more useful when you are using it as a database. It found nothing on the zero index, but anyway, you get the point. Now this is not so useful at. Now, what happens when I have hundreds and thousands of these documents and the searching? Now I have just one, and it feels it is quicker. Now that's where the Redis search and Redis indexing come handy. And I pre-created few indexes, but then let's see. I'll try to create the index again on both, on the customer, the com that's representing the customer. It's the com prefixed one, and the index would look something like this. The syntax is ft.create, and then give a name. In this case, I'm giving my id01 on. Now I'm not doing the hash, that's wrong. I want to do the redis, I mean sorry, JSON. So the name and the schema name, and we also say the prefix. It starts with the com dot, all the keys that starts with com dot, and then this is how the index is created on these fields. That's the first name is and SSN. We will one more time see how the customer object look like, then it makes sense. The customer object had, if you remember, 4-5 elements. That's first name, last name is SSN, and so on. And then the data type, first name is text, and so on and so forth. Because I pre-created, it should say index already exists. Yes, it did. Now similarly, let's try creating an index and this humongous Google Book API response as well. And here it's again, here the prefix is book, and the index is been created on a schema, that's the keyword, and then the index is created on the title, which is a text type, and then author and on id, and these three elements, and index already exists. Now that the index is already existing, now let's see how we could search using the index. And I could just use the index and say find. It precisely used the index to fetch it. And similarly, I have I think 2-3 Google documents, but I could search using the index precisely a document that contains something. Like for example, I have 2 or 3 books, and one of the books is titled Pride and Prejudice. Now I can go using the search index, I can search for precisely this title. Because see, the I don't now have to use the JSON syntax to say to use the JSON path, query path. Instead, I could go by the alias name that's been created. The alias for the title is title, and it searched by the title, and it got me the payload. And one more time, let's see the browser. In the browser, I have 2, but it retrieved me only one that has, yeah, that has precisely the Pride and Prejudice title. Now, is there an easy way than the CLI? That's where the Redis search. So here it's a nicer graphical interpretation, graphical interface. You don't have to write that long syntax. Instead, you could use it creates the syntax for you. Let's see how. So firstly, I'll select the first index, the my id01, and then see how the search that we did with ft search can be simplified. So all I have to do is this. I don't need to now do the ft dot search and the index name and so on, and then I can do this, and then it found nothing for whatever reason. But then see, it's the same command, it created the command for you. And let's change the id. Oh, it's because I used the wrong id. It's supposed to be, I think, that. Yeah, now it fetched it. Now let's see how the other one, this is the book one, and instead of doing that long search syntaxing, now I could simply say that, and it generated the equivalent command for me, and it fetched it. Now you can get an idea. This is not about it. There is much more and many more things you can do using these indexing capabilities and search and JSON together. um, but this is a gist of it. You can see how much more scope, how many more things you can do using this. And with this, let's see, go back to the presentation and then see if I have anything else left in my part 2. We saw that, we saw this, and we saw the demo. Now with this, I would conclude the part 2, and we will move on to part 3 in the next video. And in the next video, in part 3, we will see the web session data caching aspect using Redis. And we are going to use Spring Session Data libraries to do that. The web session caching is much more trickier than the other types of caches we saw, and let's see how that can be done easily. See you in the next video.